welcome. Sometimes the simplest questions are the trickiest. Today, we're tackling one of those. What does it actually cost to figure out a cost? It's a bit of a riddle, right? Well, let's dig in.
Okay, so let's imagine something big. You're about to build a huge $100 million factory. The first question on your mind, obviously, is what's this going to cost me? I mean, that seems like the most logical place to start. Or is it?
Well, here's the twist. What if I told you that's actually the wrong first question? Yeah, before we can even touch that massive $100 million figure, there's another cost, a hidden one that we have to tackle first. So here it is, the real question. What's the price of the price tag itself? Think about it. Creating an estimate isn't just a quick calculation. It's a mini project all on its own. It's got a team, it takes time, and you bet it has a cost. And that is what we're going to unpack today. All right, let's get into it. The whole idea here is a little mind-bending, but it's so important. Just the act of figuring out how much something will cost has its own price. And sometimes it's a pretty hefty one. So what does that even mean, the cost of the estimate? Well, the pros at AACE International call it the estimate preparation cost, and it's the whole shebang. We're not talking about one person punching numbers into a calculator. No way. This is about digging for data, doing these super detailed takeoffs. That's literally counting every nut, bolt, and wire from the blueprints, plus analyzing all the risks, documenting everything. It's basically a full-on forensic investigation.
Okay, so you'd think there'd be a simple formula, right? Like, oh, it's just 1% of the total project cost. Easy. But nope. When researchers actually started digging through the historical data, what they found was a total mess. Just chaos. And this one number pretty much says it all. 3 to 1. Get this. For the exact same kind of project with the same kind of estimate, they found costs that were 3 times different from each other depending on which source you looked at. That's not just a little wiggle room. That's a massive, massive difference.
And check this out. Here's a perfect example. We've got a $10 million project. It needs a pretty standard, middle-of-the-road estimate, what's called a Class 3. So one source says that'll cost you 0.8%, another says nope, it's 0.14%, and a third one comes in at just 0.07%. We're talking about the difference between, say, $80,000 and $7,000. That is a gigantic gap.
So you gotta ask, right? Why? Why is the data so wildly inconsistent? What are we missing here? It's like a mystery, and there have to be some clues.
And it turns out there are. This isn't just random noise. The researchers figured out that pretty much all of that chaos boils down to 3 key things. These are the drivers that, once you understand them, turn this mess into something that actually makes sense. Okay, driver number 1, the level of detail. This is pretty intuitive, right? A rough, back-of-the-napkin guess, a Class 5 estimate, is going to be cheap because you've barely even started the design. But if you want a super precise ironclad estimate, a Class 1, when you're basically ready to break ground, well, that takes a ton of work. It can easily cost 4 times more. More detail, more work, more money. Simple as that. Driver number 2 is the project size. And here we see this classic economy of scale thing happen. On a smaller $1 million job, the estimate might be about 0.5% of the total cost. But on a huge $100 million project, that percentage plummets. It's because some of the work to set up the estimate is the same no matter the size. So on a bigger project, that cost just gets spread thinner. And that brings us to the big one, the third driver. The AACE researchers looked at that wild 3 to 1 variation and said, you know what's causing most of this? One word, complexity. This right here is the missing piece of the puzzle. Okay, so we have our 3 clues: detail, size, and complexity. Now, how do we use them to solve the mystery? Well, the researchers built what's called a parametric model. And don't let the fancy name scare you. It's basically just a really smart formula that puts all these pieces together. And we're not going to dive into a bunch of crazy math, I promise. It's actually really logical when you break it down. You start with a base cost for the level of detail you need. Then, the formula adjusts that number based on the project's size. Then, and this is the key part, it adjusts again for complexity. And finally, it tweaks it based on how efficient your team and their software are. But what is complexity, really? I mean, it sounds a bit vague, but here are some solid examples. Low complexity, think of a standard office building. Pretty straightforward, typical, maybe a standard chemical plant. But then you get into advanced, projects using brand new, unproven tech. And it just keeps climbing from there, all the way up to very high, which is like aerospace or nuclear stuff. As that complexity level goes up, you can bet the cost to estimate it goes right up with it. All right, this is the really cool part. Let's see this formula in action. This is where we take all that messy, chaotic data we saw earlier and turn it into something crystal clear. Okay, let's start with our $10 million project, and we'll say it's typical complexity, like that chemical plant we mentioned. A real quick and dirty estimate, maybe $4,000. That class 3, the middle of the road one, we're looking at about $15,000. And the full, super detailed class 1, that'll run you $50,000. Okay, got it? Now keep those numbers in your head and watch this. We're keeping everything the same, still a $10 million project, but we're just flipping one switch. Complexity is now advanced. Maybe it's that project with some newfangled technology. And boom, look at that. The class 3 estimate jumps from $15,000 to $25,000. And the big class 1 goes from $50,000 all the way to $85,000. That right there is the massive impact of complexity. Clear as day.
So what's the big takeaway from all of this? It's that the cost of an estimate isn't just some random percentage you pull out of a hat. It's a real, dynamic number. And the best part is, it's predictable. You can actually plan for it, as long as you pay attention to those 3 key drivers: detail, size, and most of all, complexity. And that leaves us with one last question to chew on. If planning the estimate is its own project with a cost you can actually figure out ahead of time, what's the real cost of not doing that? What's the price of just winging it? Something to think about for sure.